So here we want to solve problem 7 in chapter 3, which is an examination of a block that's floating in water, and you want to think about it, or in some liquid, and you want to think about it as demonstrating simple harmonic oscillator properties. And so I'm going to declare down to be the positive x direction, and then I've drawn a force diagram here that shows that the gravity force, which is the total mass of the block times g, is pulling down, and there's some force of buoyancy that is pointing up. So the sum of the forces then is equal to mx double dot. Now, the first thing to do is to think about this problem in equilibrium. So in equilibrium, when it's just floating there, then the acceleration is 0. And what I'm going to say is that in equilibrium, the distance that the box is under the water, I'm going to call x0. And I'm going to say that the volume that the box is underwater, I'm going to call V sub E. Now, the book uses just the letter V for this, so this is the volume of the box that is under the water. And so that's going to be equal to the area of the box times x0, the area of the top of the box. So the top of the box has some area A. So now, the force of buoyancy is the volume, or is the weight of the water displaced. So that would be rho 0, V in equilibrium. So again, in equilibrium, times G, and that's going to be equal to mg. And where this m here is the total mass of the box. I'm going to use this in two different ways. One way I'm going to use this eventually is I'm going to say that the mass is equal to rho 0 times V sub E. So the total mass of the box is the density of water times this equilibrium volume. And the other way I'm going to use it is that I'm going to say that if I put in the x0, I'm going to say that the mass of the box is equal to rho 0 A times x0. So these are two different expressions for the mass of the box. One case I'm just using the idea that the mass is equal to the weight of the water displaced, which is this first one, and the second one I'm actually using the x0. So now that I know some things about the mass, I'm going to go back and look at the equation not in equilibrium where x double dot is not 0. So now if I go back to not being in equilibrium, then mg minus the force of the buoyancy is equal to mx double dot. And now I'm thinking that however far the box is down here in the water, I'm just going to call this distance x. So x is now the not equilibrium distance at which I'm down in the water. So what I'm going to do here is for this first m, I'm going to use the second expression. So rho 0 A x0. For the force of buoyancy, I'm going to use rho 0 times A times x times g. So this is now the new volume for which the box has been submerged, right? So the new volume for which the box has been submerged is A times x, and so the force of buoyancy is equal to, the mass of the water times g, and so the mass of the water would be rho 0 times the volume that's been displaced. And for the second m over here, I'm going to use rho 0 VE g. So for the second m, I'm using this other expression for the mass in terms of the VE. Now we see here that I lost a g right here, and I did something stupid. This should be an x double dot. Right, so I lost this g on the first mg term, and here the acceleration is x double dot, which is not gravity, obviously. Okay, so now when I look at this equation, I see that the rho 0 cancels out, so the density of the fluid doesn't particularly matter. And if I rewrite this, I have V sub E x double dot plus A times G times x minus x0 is equal to 0. Or I have x double dot plus A G over V sub E times x minus x0 is equal to 0. And that's essentially a simple harmonic oscillator equation. And the way I can make it exactly look like a simple harmonic oscillator equation is I can introduce y to be x minus x0. And since x0 is just a constant, then y double dot is equal to x double dot. If I make those substitutions, then my equation becomes y double dot plus ag over the volume that is submerged in equilibrium is equal to 0. And then lining that up with my simple harmonic oscillator equation ideas, I know that omega squared is then, well, omega squared is ag over v sub e. And since omega is 2 pi over the period, I can find that the period is 1 over 2 pi times the square root of VE over AG, which is the expression that you wanted to derive in the book.